All right, this is number 14 of our calculator section for the SAT math. So we have question 14, which uses this information. Remember, we're reading our question first and then determining what part of this we need, okay? So we have which graph represents the model. All right, what's the model? The given function C models. All right, so this is the model. So we don't even need this information. We just need the model, and this is the model. So we have 4.3x plus 19, and we know that's very similar to our y equals mx plus b, right? So we have m, which is going to be our slope. So m equals 4.3, just taking that value right here directly in the 1 in front of the x. And our b, which is our y-intercept, equals 19, okay? So what do those values mean? Our 4.3 means our rise over run equals 4.3. So rise over run equals 4.3 over 1, right? Because any number over 1 is itself. And then our y-intercept is 19, which means our y-intercept equals 0, 19 as an ordered pair, right? So then what we want to do is find the graph that correlates with that. The easiest way to do it is to look at slopes and see this slope is positive because it's a positive number, and eliminate any negative slopes. So that's step one. Do we have any that have a negative slope? No, that one's positive, that one's positive, that one's positive, and this one is positive. Okay, well, we tried. Next step, look at the y-intercept. We have 0, 19 because that means that's a y-intercept. That means that should be a point on our line. So any value or line that doesn't have a point at 0, 19 can't be the answer. So immediately we see this one has a point at 0, but nothing at 0, 19. Oh, tricky question. But look at the graph scale. 0 jumps to 40, jumps to 80. So maybe this is 19. Maybe it's not drawn entirely to scale. Maybe because these values are so big, maybe this is a 0, 19. So let's be careful there, okay? So this one, though, definitely doesn't have a 19 because it goes to 4 to 5. That's where its y-intercept is. This is like y-intercept of like 4.5 or something. So that's not going to be a y-intercept of 19. So it's not going to be D, right? All right, look at these. This one looks like it could be about 19 because right before 20, and this one also looks like it could be 19, right? All right, so now we have to count the slope. Get a little bit more precise with it, right? So let's find out what the slope of this line is. Let's find a value that's close here. Here's one. Actually, both these are pretty close. It actually looks like most of the time it kind of goes up by the same value. So like right here and right here, they're both crossing. We'll use this one and this one. We're going up, how many? Remember, do your scale. We're going up 20. And we're going over in the positive direction 4, 2, 4. This is not going up 2 and over 2. Use our scale. We're going up 20 and to the right 4. So slope for this one's 20 over 4, which equals 20 divided by 4 is 4. 4 divided by 4 is 1. 4 over 1 equals 4. All right. That's pretty close to 4.3, so it might be that one. Let's try this one. This one, we have a point here. We have a point about here. We go up, looks like 2. Okay, because each tick mark is 2, because 2 tick mark is 4, right? So up 2 to the right in the positive direction, 2, 4, 6, 8. So you have 2 over 8, which equals 1/4. That's not close to 4 over 3, right? Or 4.3. So 1 over 4, that is not the slope we're looking for. C, cowboy. All right, now this one. This slope might be huge because we have some huge numbers over here, right? Let's try it. We have a point here. And we have a point here. We're going to go up 80. Oh my goodness, 80. And we're going over 4. We have 80 over 4, which simplifies to 20 over 1, which equals 20. All right. Our slope being 20, that's way more than 4. So it can't be this one either. See you later, crocodile. That means our only answer left is A. And that checks out because our slope of 4 is pretty close to it. It's probably just the scale of the graph is a little off, or our math is a little estimation, which is close enough to get an approximation of the slope, but not an actual exact slope. But we're close enough. All the answers don't work. Our slope's good enough. It's an approximation, it's an estimate, right? Using our growth triangles, it might not be perfect. Maybe this point's like, instead of 12, we think it's 12.7, right? Maybe it's like 1269.2, right? Something like that. So that's why it might be a little off. Our answer is going to be A. Good enough.